Okay, so here we go. How did you do? Anybody get number one? We are doing this review sheet, pulling it all together. How many ways can I arrange these kids in a row? Answer? Guys, we should know this. In a row. How many ways can we arrange them in a row?
60.
It's something factorial. What'd you say? Someone give me the answer.
60.
Oh, dang. Well, we tried.
12 factorial. Why 12 factorial? There are 12 kids. Now, those of you that said 60, you multiplied those together. That would be, how many ways can I choose a senior, a junior, and a freshman? So I have 4 choices, 3 choices, and 5 choices. That's a whole different thing. I'm arranging these 12 kids in a row. Think of 12 blanks. How many choices for the first blank? 12. And then 11 and 10, all the way down. 12 factorial. We have talked about this. This is big. You need to know that if you have n things in a row, it's n factorial. So if you are arranging 12 people in a row, I don't care what grade they're in, what color they are, what gender they are, it doesn't matter. If I'm arranging 12 people in a row, it's 12 factorial. Now what if I'm putting them in a circle? It's 11 factorial. Because when you arrange things in a circle, it's 1 less factorial because of the rotation effect of a circle. Circles have no beginnings and no ends. If what I'm saying is foreign to you, you need to go back and watch the videos because we talked about all that. I drew out the plates of fruit in the cafeteria and we looked at how they were rotations of each other. All right. Now, did we talk about bundling? Did we talk about how we could seat all of the seniors together? What did we say? Anybody want to take a guess at this one? You're going to seat all these people in a row, but the seniors have to be together.
4 factorial.
It is 9 factorial, 4 factorial. Very good, Wyatt. Now, where did Wyatt get 9? Well, if you're making the seniors sit together, that's like tying a string around them. So they're not functioning as individuals now. You're not arranging them individually. You're arranging them as a bundle, right? So they count as 1. Now these guys are all individuals, so they count as 8. So you got 8 and 1, you got 9 things that you are arranging. But when you tied the string around the seniors, that could have been done 4 factorial ways. When we bundle, we look at the big picture. We got a group, counts as 1, and then 3 and 5. That's 9 total. But then anything that got grouped can itself be arranged. So that's 9 factorial. So that is the answer to C. That's the answer to C. Now, all students seated with their own grade. That means you got to have the seniors together and the juniors together and the freshmen together. So you have tied strings around each of these groups. All right? So how many things are you arranging big picture-wise? 3. So you're going to start with 3 factorial. Because these guys are clumped. You can't separate them. You only got 3 clumps to arrange. But when you tied the string around those seniors, how many ways could you have done it? 4 factorial, 3 factorial, 5 factorial. So it's the number of bundles factorial, and then each bundle factorial. That's how many ways they can be arranged. No freshmen on the ends. All right? There's my 12 seats. I don't care where anybody sits, but I can't have a freshman on the ends. So that means I don't have 12 options for that seat. If everybody could sit anywhere, there'd be 12 options for that seat, right? How many options do I have for that seat now? How many? 7. Because why? Can't be a freshman. So that means it must be a junior or a senior. There's only 7 of those. Now I'm going to come down here. What about that spot? There's 6 options for that spot. Because you put one of your juniors or seniors down here, you're going to put another one down there, right? Now, do I care about any of these middle 10 spots? There's 10 kids left. Would you agree?
Yeah.
Do I care about any of that?
No.
How many ways can I arrange 10 things in a row? 10 factorial. So these are just 10 factorial. 10, 9, 8, 7, 6, da, 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 da. So it's 7 times 6 times 10 factorial. We take care of the ends first because those are the seats that have restrictions. Right? So we take care of the restrictions and then just fill in everybody else. DeAndre, you had your hand up.
Oh yeah. I wanted to know, like, if we were doing like a quiz or something, could we leave it as factorial, or would you want us to simplify it?
I want you to simplify it.
Okay.
I don't want to take class time typing all this in on the calculator. But since he asked, let's make sure everybody remembers. These factorials you can calculate on your calculator using the factorial button, which is located in the math prob menu. Remember? So you press the math button, click across to the prob option, and then you'll see the factorial right there. All right, how many ways can the letters of push-ups be arranged? All right. How many letters do we have? Let's count them up. There's 7 letters. I am arranging 7 things. That's 7 factorial. Period. You can arrange 7 things in a row, 7 factorial ways. But what?
The letters are repeated.
Some of them are duplicates. How do we handle duplicates? We divide. So what have we got? We've got 2 P's. Now we divide by each duplicate factorial. So I have 2 P's, I have 2 U's, and 2 S's. Now when I type this into my calculator, make sure you have parentheses around your denominator. Anytime, whether it's factorial or cosines or anything, if you have more than one thing in the denominator, you have to have it in parentheses. Okay, now, I think it's question 3 where where we need to spend some time talking about this. Have we discussed combinations and permutations?
No.
I didn't think so. So that's what we're going to do right now. So I want you to look at, in number 3, I want you to look at questions B and C. So in number 3, I want you to look at questions B and C. Now, both questions involve 20 students and my choosing 3. Would you agree with that? In one case, I'm going to choose 3 of you, and you are all going to get a Ticonderoga pencil, the best pencils ever made. You're all going to get a Ticonderoga. In question C, somebody's going to get a calculator, somebody's going to get a pencil, and somebody's going to get an eraser. Now, are these the same question? Well, they have the same answer. They're basically the same thing, 20 choose 3. Is there any difference there? Patty?
They're all different objects?
Well, in the second question, yes, you're giving away different objects. Does that make a difference mathematically, Patty?
That I'm not sure about. Then again, I wasn't here Thursday, Friday, so.
Well, we've not talked about this, so you have a good chance as everyone else. What's your initial thought? Do you think it
I
makes...
want to say no, but I feel like it's yes. So
Go with your
I'm
feeling.
conflicted.
Go with your feeling. Your feeling is
I
right.
feel like it does make a mathematical.
It does make a mathematical difference, and here's why. Let's say these are the 3 I pick right here. All right, these are the three that are gonna get the prize. If I give everybody an identical pencil, does it matter the order I hand them out? I mean, if I give her a pencil, her a pencil, her a pencil, does it matter if I start on this end or that end? Hand them out. Everybody's getting a pencil, right? But if I'm giving away a calculator, a pencil, and a marker, does it matter if I start at this end with the calculator or if I start at that end with the calculator? It's the same three kids, but they're getting a different thing, right? So it's really a different situation. Problem B, where the order doesn't matter, is called a combination problem. And in this case, it would be written as 20C3. The C stands for combinations. Some people think of it as choose, because it really is. 20C3, sometimes it's written like this. It just depends on what book you're looking at. So be familiar with both notations. They mean exactly the same thing. And they mean, what this means to me is, there are 20 total whatevers. I'm going to pick 3 of them, in this case people, and the order doesn't matter. So this would be giving away the 3 pencils. If we had to do it by hand, this is the calculation that's involved. If we had to do it by hand. Now I say if, because I don't know if you've paid attention, but when you've gone to your factorial button, you actually have a button on your calculator that looks like that. And we're going to use that button. Okay, so get your calculators out. Press 20. You got to press this number first. Press 20. And then do math, prob, and find the NCR option. Press it. And then press 3. And then press enter. And what does it tell you the answer is?
1,140.
What?
1,140.
1,140 is the answer. So there would be 1,140 ways that I could give away 3 pencils to these 20 students. The little formula, the 20 factorial over the 17 factorial, can you kind of see where that came from? It's this number divided by them subtracted. Oh, wait. I'm wrong. There's a 3 in there too. So it's n minus r factorial, r factorial. That's your formula for combinations, if you had to do it by hand. Now, when are you going to have to do it by hand? Well, if I get mad at you and don't let you use a calculator. Right? So let's not make me mad, because then all we have to do is press 20 and CR3, and it calculates it for us. Okay? Now, what about the other question? Question C. Now, in question C, we agreed order matters. Right? We're giving away 3 different prizes. Somebody said that. The prizes are different. We're giving away different prizes. So the order matters. You want the calculator. So it matters if I pick you first or second or third. When order matters, it's called a permutation. And in this case, it's almost identical notation, except it's a P instead of a C. And again, you can have this, both, it's written both ways. And the little formula here would be 20 factorial over 17 factorial. That's the formula for permutation. But again, you've got this button on your calculator, so you're going to press 20, then you go to math, prob, NPR, 3, and what's that answer?
6,800.
And the formula for that, permutations and then things are at a time, is so our biggest dilemma, I mean, obviously typing it on the calculator is easy. The biggest thing you're going to need to think about when you read a problem is if you got a group of something and you're choosing some from the group, you need to think about, does the order matter or does it not? If the order doesn't matter, it's a combination. If it does matter, it's a permutation. Okay? So let's look at question A in number 3. How many committees of 5 can I make? All right, now wait a minute. There's 20 kids, and I'm going to pick 5 for a committee. So your options are 20C5 and 20P5. Think about it now for a minute. You've got 20 kids, you're going to pick 5. Does the order matter if you're making a committee? Nope. You just want to be picked, right? You don't care if you're picked first, second, third. You don't care. You just want to get picked. So the answer to the question would be 20C5 because combinations are no order. Order doesn't matter. Okay, so we go to our calculator. We type in 20. Math, Prob, NCR, 5. And the answer to the question is 504. There we go. That's how many different committees could be formed.
So are we supposed to use 20 and 5 if it's 2 boys and 2 girls?
We're on A.
Oh.
We're on question A. Now we're going to go to question D, which is a different question now, right? So here we go. We're going to make committees, but now my committee is a little bit more specific. I need to pick 2 girls and 2 boys. Okay. Anybody have a thought about that? Let's see, I've got 12 girls and 8 boys. And I'm going to pick a committee of 4 now, but it's specific. So even though I'm picking 4, I wouldn't say 20C4 because 20C4 might include all girls, right?
12C4.
12C4?
12C2.
12C2. And what does that do? 12C2 picks 2 from the girl pile. And then I'll do 8C2. That picks 2 from the boy pile. Now what do I do with those 2 numbers? I am picking 2 boys and 2 girls. What do I do with them? No. When the mathematician says and, it's a multiply. This is like picking a jumper and a shirt. We multiply them. Fundamental counting principle, we multiply them. So there's this many ways I can pick 2 girls, and there's this many ways I can pick 2 boys, so I'm going to multiply those together. Now, if it said 2 girls or 2 boys, add. That's the total. I can do girls this many ways, I can do boys this many ways, so altogether I can do it this many ways. If you are doing them at the same time, if you are picking boys and girls, you're going to multiply. Listen to me, this is another biggie. If you are doing things at the same time, this and this, you multiply. If it's this or this, then you add. Okay? How many committees with all boys can I form if the committee can have any number of members? Oh, Lord. Okay, now I can have any number of members. So what does that mean? It could have 1, or 2, or 3, or 4, or 5, or 6. Am I going to go all the way to 20? I'm only going to go to 8 because what's the stipulation? All boys. I only have 8 boys. But I could have this or this or this or this or this. What am I going to do here? I'm going to be doing a bunch of addition, aren't I? So here we go. Suppose I want 1 committee member. Well, the answer is 8. technically 8C1. There are 8 boys, and you are going to pick one of them. Now, if you calculated that, that's 8. That's the number 8. You can pick Joey, Bobby, Billy, John, right? Now, what about 2 committee members? What would that look like? That'd be 8C2. Don't you want to pick 2 from the boy pile? And then what are you going to do with all of those numbers? There's a whole bunch of numbers there. What are you going to do with all of them? Add them up. We're not going to do it. That takes too long. But that's what you would do. Okay, why is that an addition? Because it's 1, or 2, or 3, and anytime it's or, it's add. Okay? Now, I want to give you one more. It's not there on the paper. I know there's one more in there, but while we're here, I want to talk about one more kind of problem. Let's suppose we're going to choose a 5-card hand. And let's say we want exactly 2 diamonds. And let's say we want no more than 2 diamonds. 2 different questions here. All right, so here we go. We're heading toward probability, where we're going to talk about what's the probability, you know, different stuff. So we need to, let's introduce the card problems. 5-card hand, I want exactly 2 diamonds. All right, so what does that mean? It means I want 2 diamonds and what? 3 of something else? We're doing this question right here, question number 1. We want exactly 2 diamonds. So that means 2 diamonds and 3 non-diamonds. Right? So pretend I have my deck of cards right here. I'm going to split it into 2 piles. Here's going to be the pile of diamonds, and here's going to be the pile of everything else. How many cards are in the diamond pile?
2.
How many? 13? Okay, you guys have seen a deck of cards before, right? You need to be familiar with a deck of cards. So let's just run through it real quick. How many cards total? 52. Divided into 4 groups called suits. 2 of the suits are black, 2 of the suits are red. The black ones are spades and clubs. The red ones are diamonds and hearts. Since there are 52 cards divided up into 4 equal groups, there's 13 in every suit, right? So we got 13 diamonds, we got 13 hearts, 13 clubs, 13 spades. So my 2 piles are 13 diamonds right here and 39 everything else. Now when I build this hand, what am I going to do? Think of it like boys and girls. I'm going to pick 2 cards out of my diamond pile. So what's that going to look like mathematically? 13C2. I don't care the order. I need 2 diamonds. I don't care if I get the 3 diamonds and then the 4 diamonds, or the 5 and then the jack. I don't care. Order is not important. I just want 2 diamonds. So 13C2. You got it? Now, what else am I picking? I need 5 cards altogether, so I got to pick 3 more, right? If they're coming out of this pile over here, 39C3. Now, I am picking 2 diamonds and 3 other cards. So what am I going to do to these 2 numbers? Multiply them. Multiply, multiply, multiply. If you are doing both things, this and this, you multiply. It didn't say pick 2 diamonds or 3 other cards. That doesn't make any sense. I need 5 cards altogether. So it's 2 and 3. All right, now what about this? No more than 2 diamonds. What does that mean? That means I could have a hand that had 2 diamonds, right?
One.
Or I could have a hand that has 1 diamond.
Zero.
Or I could have a hand that has no diamonds, right? What do those ors mean I'm going to be doing?
Adding.
I'm going to be adding up different options. I have options in this problem. When you have different options, you add them up to get the total options. All right, so 2 diamonds I already did. That would be 13C2, 39C3. Everybody okay with that? That was our previous problem. Exactly 2 diamonds. What would 1 diamond look like? I want a 5-card hand with 1 diamond. What would that look like?
C1.
13C1,
39C3.
39C4. Right? Because we need 5 cards. Don't lose sight of that. You got to have 5 cards. If one of them's a diamond, the other 4 are something else. How about 0 diamonds? 39C5. Now, if you want just to make it kind of match, you can add, or not add, but you can include 13C0. That would be 13 diamonds in this pile, but I'm not picking any. You don't, since you're not picking any, you don't need to include that, but that's technically what's there. 13C0, 39C5. So then you would calculate that. That's a multiplication, 2 diamonds and 3 other cards. You would calculate this, calculate that, and then once you get all those calculated, you would add them up. Ross?
What if you left the 13C0 in the multiple?
13C0 is just 1.
Okay, so it wouldn't affect you.
It's not going to affect your answer at all. Yeah, so you can take it or leave it. Okay? All right, last question on the sheet, and then we'll talk about a little something else. How many diagonals does an octagon have? Now, you, especially if you had Mr. Schroeder, you learned a little formula for this. You don't need a formula for it though. I want you to think about something for a minute. You know what an octagon is, right? Right?
Yeah.
Humor me. Say, yeah, we know what an octagon is.
Yeah.
There we
What's
go.
an
Thank
octagon?
you. All right. So it's got 8 sides, right? And when we make a diagonal, okay, so we got these 8 points. Here they are. 8 points for a diagonal or for a octagon. You're joining 2 of those points, right? So if I want this diagonal, I'll join those 2 points, and this diagonal would join those 2 points. So basically, one way of thinking about this problem, if you don't remember your formula from geometry, one way of thinking about this problem is to say, okay, there's 8 points, and I am choosing 2 of them to join at a time. So 8 points, choose 2 of them to join at a time, right? And why did I use a C and not a P? Because when I draw this diagonal, it doesn't matter if I do this one to this one or this one to this one, right? They're the same. So 8, choose 2. Now there's something wrong with that. It's a great strategy, but there's something wrong. Ross?
Does that include the size?
Oh, does that include the sides? Yes, it does. Because this includes joining every pair of points. Well, we can fix that easily. We don't want the sides, right? How many sides are there? So if we just take this number minus 8, that will tell us how many are the diagonals. Because 8C2 is every segment in that picture, including this one and this one, and I don't want those. There's 8 of those that I don't want. 8C2 is every segment, every possible pairing. There's 8 of those I can't count as diagonals, so that would be the answer. If it were a 12-sided figure, what would you have? 12C2 minus 12? together, we're gonna have a little quiz. It would behoove you to have a calculator. And everything we talked about so far is fair game. What I want to do right now is have you look in your packet. You got a couple minutes. Will you look on page 3? Page 3 of the packet, it's numbered. It says 3 at the top. How many outfits can I make with 3 jumpers and 4 shirts? No. Whoa.
4 factorial times
No,
3
no,
factorial.
no,
2
no,
factorial.
no.
7.
Guys. I
7
go to my
factorial.
closet. Somebody said 12 and you're right. I go to my closet. I need to pick a shirt. I need to pick a jumper. How many ways can I pick a shirt and pick a jumper? 12.
In a row.
If you're doing factorials, if you said 3 factorial, 4 factorial, think about that. That would be a whole bunch of blanks. 3, 2, 1, 4, 3. You're not arranging. I'm not arranging my shorts and jumpers. This would be like laying them out on the floor and arranging them.
I like to go
I'm
around.
not doing that. I'm picking a shirt and picking a jumper. Okay, Tommy?
So when you're making outfits with more than 2 things, like 3 jumpers, 4 shirts, like 2 hats, you can still just times 2.
Yep, it would be 3 times 4 times 2. Yep. How many license plates can be made that contain 3 letters followed by 2 digits? No digits can repeat. 26 times 26 times 26, because the letters can repeat, times 10 times 9. No factorials. I'm not arranging anything. I'm saying I need to build this license plate. How many options do I have? I need to make an outfit for myself. How many options do I have? I'm not arranging. There's no factorials here. How many committees of 5 can be made from a group of 12? Is that 12 C5 or 12 P5? C5. C5. How many ways can I give away a calculator, pencil, and eraser to, oh, this is coincidental, to 3 people in a class of 20? That would be 20 P3. Why? Because the prizes are different. How many different 5-card hands are possible from a standard deck? 52 C5. We don't care what order you draw the cards. The 5 cards are the 5 cards. How many 5-card hands that contain 3 diamonds and 2 clubs are possible? 5-card hands contain 3 diamonds and 2 clubs. What's that gonna look like? 13 C3. What's that? 3 diamonds. Why 13? That's how many diamonds there are. Pick a 3. Now I want 2 clubs. 13 C2. What do I do to those 2 numbers? Multiply diamonds and clubs. Finally, in numbers 3, 4, and 5, what does the P stand for? Permutation. The word permutation. All right, I will see you tomorrow. Please bring me those permission slips. I don't want to have to hunt you down. Papers are due tomorrow. Big day tomorrow. Field trip on Tuesday.
Oh, Taylor.
No school on Friday.